Preparing for an API development interview? You've reached Candy Mentor, and this video is for you. We'll walk through 15 key questions you're likely to face. For each question, you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. What is the difference between REST and SOAP APIs, and when would you choose one over the other? REST and SOAP solve integration differently. REST models resources over HTTP using verbs like get, post, put, and delete, usually with JSON. It is lightweight, cache-friendly, and easy for web and mobile clients. SOAP is protocol-heavy, XML-based, and has formal contracts through WSDL plus built-in standards for security and transactions. I would choose REST for most public APIs, but SOAP can still fit strict enterprise integrations. While answering, focus on architectural differences, data formats, transport assumptions, contracts, performance, security standards, and when a team would choose REST, SOAP, GraphQL, or gRPC in real systems. Question 2. How do you handle API versioning without breaking existing clients? Versioning protects clients when an API evolves. I prefer non-breaking changes first. Add optional fields, new endpoints, or tolerant parsing. For breaking changes, I usually expose a clear version, commonly /v1 or a vendor media type, document migration steps, and run both versions during a deprecation window. The key is contract stability. Clients should not wake up broken because the server renamed a field or changed response semantics. Make sure to cover backward compatibility, breaking versus non-breaking changes, URL and header versioning, deprecation windows, migration documentation, and why stable contracts matter for external API consumers. Question 3. What does idempotency mean in API design, and why is it important? Idempotency means repeating the same request produces the same final state. Get, put, and delete should generally be idempotent, while post often creates a new resource each time. For payments or order creation, I add an idempotency key header and store the first result against that key. If the client retries after a timeout, the server returns the original outcome instead of charging twice in production. In your answer, talk about repeated requests, HTTP method semantics, retries, duplicate prevention, idempotency keys, payment or order examples, and how servers store request outcomes safely. Question 4. How do you choose the right HTTP status code for an API response? Status codes are part of the API contract, not decoration. I use 200 for successful reads, 201 when a resource is created, 204 for success with no body, 400 for validation issues, 401 for unauthenticated users, 403 for forbidden access, 404 for missing resources, 409 for conflicts, and 500 only for unexpected server failures. Correct codes help clients handle retries, user messages, and monitoring cleanly. Be sure to mention common 2xx, 4xx, and 5xx codes, client versus server responsibility, validation errors, authentication failures, conflicts, and how status codes guide client retry behavior. Question 5. How would you implement authentication and authorization for a secure API? Authentication proves who the caller is. Authorization decides what they can do. For user-delegated access, I use OAuth 2.0 with short-lived access tokens and refresh tokens. JWTs work well when services need to verify claims without a database lookup, but they require careful signing, expiration, rotation, and audience checks. API keys are simpler for server-to-server identification, but they should be scoped, rotated, and never treated as user identity. While answering, cover authentication versus authorization, OAuth 2.0, JWTs, API keys, scopes, token expiration, refresh tokens, signature validation, and secure storage of credentials and secrets. Question 6. How do you design rate limiting for a public API? Rate limiting protects availability and fair usage. I would define limits by API key, user, IP, or tenant, depending on the business model. Common algorithms are token bucket, leaky bucket, fixed window, and sliding window. Token bucket is flexible because it allows short bursts. When a caller exceeds the limit, I return 429 with retry after and clear headers showing remaining quota. Premium tiers can simply receive higher quotas. Make sure to discuss rate limit dimensions, token bucket and sliding window algorithms, 429 responses, retry after headers, abuse prevention, user tiers, distributed counters, and fairness under load. Question 7. What pagination strategy would you use for a large API dataset? Pagination keeps APIs fast when datasets grow. Offset pagination is simple, limit equals 20 and offset equals 40, but it becomes slow and inconsistent on changing data. Cursor pagination returns a token based on a stable sort key, such as created at plus ID, and is better for feeds or large tables. I also include total counts only when they are cheap, because counting huge filtered datasets can hurt latency under load. In your answer, compare offset and cursor pagination, stable sorting, filtering, total counts, consistency during updates, performance on large tables, and response metadata such as next cursor links. Question 8. How should an API return validation errors to clients? A good error response helps both humans and machines. I return a consistent structure with code, message, field-level details, trace ID, and optionally documentation links. The message should be safe and actionable, not a stack trace or database error. For validation failures, I group all field errors so clients can fix them in one pass. Consistency matters more than inventing a different format per endpoint. Be sure to cover consistent error schemas, machine-readable codes, human-readable messages, field-level details, trace IDs, avoiding sensitive internals, localization, and helping clients recover from bad requests. Question 9. How would you design and secure webhooks for an API platform? Webhooks are outbound APIs triggered by events. Instead of clients polling every minute, the server pushes events like payment.succeeded or order.shipped to a registered callback URL. I secure them with HMAC signatures, timestamp checks, retries with backoff, and event IDs for deduplication. The receiver must be idempotent because delivery can happen more than once. For reliability, I expose logs and a replay option to customers. While answering, focus on event delivery, callback URLs, HMAC signatures, timestamp validation, retries, exponential backoff, deduplication, idempotent receivers, event logs, and replay support for failed deliveries. Question 10. How does HTTP caching work, and how can it improve API performance? HTTP caching reduces latency and backend load. For public or stable resources, I set cache control with max age and sometimes CDN caching. ETAG and last modified support conditional requests. The client sends if none match, and the server can return 304 instead of the full body. I avoid caching personalized or sensitive data unless vary headers, private directives, and authorization behavior are clearly handled by the platform, correctly end-to-end. Make sure to mention cache control, ETAG, last modified, conditional requests, 304 responses, CDN caching, cache invalidation, personalized data risks, and when not to cache responses. Question 11. What is OpenAPI, and how do you use it in API development? OpenAPI is the executable contract for an API. I use it to describe endpoints, schemas, parameters, authentication, examples, and error responses. From that contract, teams can generate documentation, SDKs, mock servers, and contract tests. It also improves design reviews because breaking changes become visible before code ships. The best APIs keep the spec in source control and validate implementation against it in CI on every build. In your answer, talk about API contracts, schemas, examples, documentation generation, SDK generation, mock servers, contract testing, design reviews, and keeping specifications synchronized with implementation. Question 12. What are the most common API security risks, and how do you prevent them? API security starts with reducing trust. I validate every input, enforce authentication and authorization on each request, use TLS everywhere, and apply least privilege scopes. I also protect against injection, mass assignment, broken object-level authorization, and excessive data exposure. Operationally, I add rate limits, audit logs, secret rotation, and dependency scanning. The common failure is trusting the client to send only allowed fields or resource IDs. Be sure to discuss input validation, TLS, least privilege, OWASP API risks, broken object level authorization, mass assignment, injection, rate limiting, logging, dependency security, and secret rotation. Question 13. What is the role of an API gateway in a microservices architecture? An API gateway is the front door for services. It centralizes cross-cutting concerns like routing, TLS termination, authentication, rate limiting, request transformation, and observability. Without a gateway, every service tends to re-implement those features inconsistently. I still avoid putting business logic there. The gateway should enforce policy, not own domain decisions. For microservices, it also simplifies client access by hiding internal topology from consumers cleanly. While answering, cover routing, authentication, rate limiting, TLS termination, request transformation, observability, centralized policy enforcement, service discovery, avoiding business logic, and simplifying client access. Question 14. How would you handle large file uploads or downloads in an API? Large uploads should not flow blindly through application servers. I usually generate a pre-signed object storage URL, let the client upload directly, then store metadata through the API. For downloads, I support streaming, range requests, and proper content types. If the API must accept large payloads, I enforce size limits, timeouts, virus scanning, and resumable uploads. This keeps compute services responsive and reduces failure impact significantly. Make sure to mention streaming, multi-part uploads, pre-signed URLs, object storage, size limits, timeouts, virus scanning, resumability, metadata handling, and preventing application servers from becoming bottlenecks. Question 15. How do you monitor and test APIs before and after production release? Production APIs need visibility, not guesses. I track latency percentiles, request rate, error rate, saturation, and business-level metrics per endpoint and tenant. Every request gets a correlation ID that flows through logs, traces, and downstream calls. For testing, I combine unit tests, integration tests, contract tests, and load tests. The goal is to detect regressions before release and diagnose incidents quickly after release in production. In your answer, talk about unit, integration, contract, and load testing, latency percentiles, error rates, tracing, correlation IDs, logs, alerts, dashboards, SLOs, and production incident diagnosis. If you are still with us, congratulations. You are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.